What if I told you that 2026 isn't just another year on the calendar, but the moment Earth enters a dangerous new phase? Not next century, not generations from now, now. Across the globe, scientists are quietly reaching the same conclusion, and it's unsettling. Climate researchers, geologists, space agencies, atmospheric scientists, all pointing to one shared reality. Multiple Earth systems are destabilizing at the same time. Natural cycles are sinking in ways we've never documented before. And 2026 may be the point where warning signs stop being theoretical and start becoming unavoidable. This is not speculation, this is not social media hype, and this is definitely not fear-mongering, this is data. Over the last few years, we've seen records shattered, not by small margins, but by massive ones. Heat levels once considered impossible. Storms growing stronger, slower, and more destructive. Seismic and volcanic regions showing unusual activity. And above us, the sun entering one of its most intense cycles in decades, sending powerful solar storms directly toward Earth. Scientists are looking at these signals and saying something chilling. What we're witnessing now is only the beginning. Because Earth doesn't change in isolation. When one system shifts, it pressures another, and when multiple systems shift together, the consequences multiply. The danger isn't one single disaster. It's overlap. Extreme weather hitting multiple continents at once, power grids under stress, food systems disrupted, communication networks vulnerable to solar activity. Modern civilization is advanced, but it's also fragile. And here's the part most people don't realize. The effects we may experience in 2026 are the result of decisions, emissions, and pressures from decades ago. In other words, much of what's coming is already in motion. So in this video, we're breaking down what's actually happening beneath the headlines, why scientists are watching 2026 so closely, and what this critical moment means, not just for the planet, but for humanity itself. This isn't about panic. It's about awareness, because once you understand what's unfolding, you'll never look at the future the same way again. Stay with me. For decades, scientists believed that Earth's changes would unfold slowly, almost quietly. Gradual warming, gradual sea level rise, gradual loss of ecosystems over centuries. That assumption shaped global planning, policy, and even public awareness. But new climate models are delivering a far more unsettling message. Earth doesn't always change gradually. Sometimes it changes suddenly. Scientists now describe this behavior with one chilling term, non-linear change. In simple terms, non-linear change means systems don't collapse step by step. They absorb pressure, they stabilize, they appear normal, and then, without warning, they cross a threshold and break. Like a stretched rubber band snapping. That's what concerns researchers today, because many of Earth's most critical systems are now operating dangerously close to those breaking points. According to updated global climate projections, the window between 2025 and 2027 represents a convergence period, a time when multiple stressors overlap instead of acting independently. And 2026 sits directly at the center of this convergence. Climate scientists warn that global temperatures may temporarily exceed 1.5 degrees Celsius above pre-industrial levels during this period. While that number might sound small, its impact is enormous. It represents a threshold that dramatically increases the likelihood of extreme weather, ecosystem disruption, and long-term instability. At the same time, Arctic ice loss is accelerating toward irreversible feedback loops. As reflective ice disappears, darker ocean water absorbs more heat, speeding up warming even further. This process doesn't slow itself, it compounds. Ocean scientists are also monitoring troubling signals within major circulation systems. Currents that regulate global climate patterns are weakening, disrupting rainfall, temperature balance, and marine ecosystems worldwide. When oceans destabilize, weather becomes more chaotic and less predictable. And perhaps most noticeably, extreme weather is no longer an exception. Heatwaves once expected every 50 years are now happening every few summers. Floods are becoming more intense and more frequent. Storms are growing stronger and lingering longer over populated areas. This isn't random. Scientists refer to this moment as a risk amplification phase. In a risk amplification phase, small disruptions no longer stay small. A single heat wave can trigger power failures. A regional drought can ripple into global food shortages. One extreme storm can strain financial, insurance, and emergency response systems simultaneously. The danger isn't one catastrophic event. It's stacking. When multiple stresses occur at the same time, the margin for recovery disappears. That's why researchers are paying such close attention to 2026. Not because it marks the end, but because it may mark the moment Earth systems begin responding faster than human systems can adapt. Small disturbances, massive consequences, and the uncomfortable truth is this: once these thresholds are crossed, there is no rewind button, only adaptation and consequences. Let's talk about what you're already feeling, not what scientists predict decades from now. Hotter summers that don't cool down at night, sudden cold snaps that arrive without warning, floods in regions that once struggled with drought. This isn't bad luck. And it isn't coincidence. Earth's climate system is becoming increasingly unstable, and the evidence is showing up in everyday life. In recent years, heat waves have shattered records not by tiny margins, but by several degrees at once. Temperatures once considered statistically impossible are now being measured across entire regions. These aren't just uncomfortable days, they're heat events that stress human health, agriculture, and energy systems simultaneously. At the same time, rainfall patterns have become dangerously erratic. Storms are dumping months' worth of rain in just a few days, overwhelming drainage systems, flooding cities, and triggering landslides. Infrastructure designed for a stable climate simply cannot keep up with this level of intensity. And storms themselves are changing. Hurricanes and major weather systems are becoming stronger, slower, and more destructive. Instead of moving quickly and dissipating, they now linger, stalling over cities, releasing relentless rain and amplifying damage. The result is longer recovery times and higher economic losses. Scientists warn that by 2026, extreme climate events may evolve in ways we've never experienced before. Events may last longer, pushing heat stress, flooding, and power demand beyond safe limits. They may cover wider regions, affecting multiple states or even entire continents at once. And most concerning, they may strike simultaneously in different parts of the world. That's the part that truly alarms experts, because when disasters occur one at a time, the global system can respond. Aid is redirected, resources are shared, emergency systems mobilize. But when multiple crises happen at the same time, the entire structure begins to strain. Food supply chains are among the first to suffer. Extreme heat and unpredictable rainfall reduce crop yields, disrupt harvest schedules, and increase prices worldwide. A drought in one region combined with flooding in another can ripple across global markets in weeks. Energy grids are another weak point. Heat waves push electricity demand to record highs while storms damage infrastructure. Power failures during extreme conditions can quickly become life-threatening, especially for vulnerable populations. Even financial systems feel the pressure. Insurance providers are struggling to keep up with repeated billion-dollar disasters. Coverage becomes more expensive or unavailable, leaving communities exposed. This isn't about one hurricane, it isn't about one flood, and it isn't about one heat wave, it's about system overload. A climate that no longer behaves within predictable limits puts every interconnected system at risk. And scientists warn that we are rapidly approaching a point where extreme events stop being rare disruptions and start becoming the background condition of everyday life. That's the reality the world is moving toward. And by 2026, it may no longer be possible to ignore it. Now here's something most people aren't talking about, but scientists are watching very closely. Earth's magnetic field is weakening. Not collapsing, not vanishing, but weakening. And that distinction matters. Earth's magnetic field acts like an invisible shield, protecting the planet from harmful solar radiation and charged particles streaming from the sun. Without it, modern life as we know it simply wouldn't function. Researchers monitoring Earth's core have observed several concerning changes. The planet's magnetic poles are moving faster than expected, drifting in ways that suggest instability deep within Earth's interior. At the same time, scientists have identified growing weak zones in the magnetic field, most notably over the Atlantic, where radiation exposure at high altitudes has already increased. These weak spots make Earth more vulnerable to solar activity, and that vulnerability is increasing at the worst possible time. Because the Sun is entering a highly active phase. Solar cycle 25, which follows an approximately 11-year rhythm, is expected to peak between 2025 and 2026. During these peak periods, the Sun produces more intense solar flares and powerful bursts of charged energy known as coronal mass ejections. When those eruptions are directed toward Earth, they can trigger geomagnetic storms. In the past, such storms were mostly a scientific curiosity. Today, they're a serious global risk. Modern civilization depends on technology that is extremely sensitive to solar disturbances. Satellites that handle navigation, communications, weather forecasting, and military systems are all exposed. A powerful solar storm could disrupt or permanently damage these systems within hours. On the ground, power grids are also at risk. Strong geomagnetic storms can induce electrical currents in transmission lines, overheating transformers, and causing widespread blackouts. In severe cases, restoring power could take weeks or longer, and then there's communication. A major solar event could disrupt GPS signals, interfere with aviation systems, and even impact global internet infrastructure. Financial transactions, emergency services, and supply chain logistics all rely on stable connectivity. The last truly extreme solar storm, known as the Carrington event, occurred in 1859, long before satellites, power grids, or digital networks existed. If a similar event happened today, the damage would be unprecedented. That's why scientists are clear about one thing. This is not a question of if a major solar storm will hit Earth. It's a question of when, and with a weakening magnetic field and an increasingly active Sun, the risks during the 2025 to 2026 window are higher than many people realize. Quietly and without headlines, Earth's protective shield is being tested. Increased seismic instability. Earthquakes and volcanic eruptions have always been part of the planet's natural behavior. But what concerns scientists today isn't individual events, it's pattern changes. Researchers analyzing global seismic data are noticing shifts that are difficult to ignore. First, earthquakes are becoming more clustered. Instead of isolated events spaced far apart in time, seismic activity is appearing in tighter sequences across multiple regions. This clustering suggests stress is being redistributed through Earth's crust more rapidly than before. Second, volcanic unrest is rising worldwide. Volcano monitoring systems, from the Pacific Ring of Fire to Iceland to parts of the Mediterranean, are detecting unusual signals, increased gas emissions, changes in magma movement, ground deformation around volcanic chambers. These signs don't always lead to eruptions, but they indicate growing pressure below the surface. Scientists are careful with their language. They avoid dramatic claims. They rarely use words like surge or explosion without certainty. But many agree on this. Earth's internal systems are under greater stress than in previous decades. One reason lies in a connection most people never consider. Climate change doesn't only affect the atmosphere and oceans, it also affects the solid Earth. As massive ice sheets and glaciers melt, especially in polar and high-altitude regions, they remove enormous weight from Earth's crust. That weight once acted like a stabilizing force. When it disappears, the crust can rebound, a process known as isostatic adjustment. This rebound changes pressure along fault lines. In some regions, it may increase the likelihood of earthquakes. In others, it may alter magma pathways beneath volcanoes, increasing unrest even if eruptions don't occur immediately. Scientists are particularly focused on areas where ice loss, tectonic boundaries, and volcanic systems overlap. These regions are considered stress-sensitive zones, meaning relatively small changes can have outsized effects. Importantly, this does not mean climate change directly causes earthquakes, but it can act as a trigger, nudging already stressed systems closer to movement. What makes this period concerning is timing. As climate-driven changes accelerate, they coincide with natural tectonic cycles that were already underway. The result is a planet experiencing multiple layers of pressure at once, from above and below. The danger isn't a single catastrophic quake, it's unpredictability, more frequent seismic swarms, more volcanic systems requiring constant monitoring, More regions facing compound risks: earthquakes, eruptions, landslides, and tsunamis. Modern cities were not built with this level of complexity in mind. And while scientists emphasize that Earth has gone through dramatic shifts before, they also point out a crucial difference. Never before has human civilization been so dense, so interconnected, and so dependent on stable ground. What's happening beneath the surface may not make daily headlines, but quietly, steadily, the planet is adjusting, and those adjustments are adding another layer of uncertainty to an already stressed world. Here's the part that truly worries experts. Not what's happening to the planet, but what's happening to us. Modern civilization is more interconnected than at any point in history. Information, energy, food, and finance flow across the globe in real time. That interconnection has created efficiency, speed, and convenience, but it has also created fragility. Because systems built for efficiency are often not built for stress. A single disruption today doesn't stay local. It ripples outward, triggering chain reactions across multiple sectors at once: food, energy, transportation, healthcare, and finance. When one system stumbles, others are pulled down with it. By 2026, scientists and risk analysts warn that this vulnerability may become impossible to ignore. Agriculture is one of the most exposed systems. Rising temperatures and unpredictable rainfall place crops under constant heat stress. Harvest windows shrink. Yields become inconsistent. A poor growing season in one region can raise food prices worldwide within weeks. When multiple agricultural zones are hit at the same time, shortages move quickly from regional to global. Water security is another growing concern. Heat increases evaporation, while altered rainfall patterns reduce reliable freshwater supplies. By 2026, millions could face water shortages, not because water disappears, but because infrastructure and distribution systems cannot adapt fast enough. Coastal cities sit at the front line. Higher sea levels combined with stronger storms increase flooding risk, even on calm days. Drainage systems designed decades ago struggle to cope. Each flood doesn't just damage property, it disrupts transportation, power, hospitals, and emergency services simultaneously. Healthcare systems, already strained in many countries, are particularly vulnerable. Heatwaves increase hospital admissions. Extreme events disrupt supply chains for medicine and equipment. When disasters overlap, capacity disappears quickly. And then there's the economy. Insurance providers are facing repeated, record-breaking losses. Coverage becomes more expensive or unavailable, leaving individuals and businesses exposed. Financial markets react to uncertainty, amplifying stress during already fragile moments. But the most dangerous factor of all is inequality. Disasters don't hit everyone equally. Communities with fewer resources recover more slowly. Repeated disruptions deepen economic divides, making each future crisis more damaging than the last. This is why experts emphasize one critical point. The danger isn't extinction. Humanity is not facing sudden annihilation. The danger is instability. A world where crises overlap faster than governments can respond. A world where recovery never fully completes before the next shock arrives. A world where resilience matters more than growth. Scientists warn that without stronger adaptation, better infrastructure, smarter planning, and more resilient systems, the years ahead could feel increasingly chaotic. Not because the planet is ending, but because the systems we rely on were never designed for this level of pressure, and by 2026, that reality may become impossible to ignore. So why do scientists keep repeating the same phrase? This is just the beginning. Not to alarm, but to explain. Because Earth systems don't respond instantly. They operate on delays, sometimes spanning years, sometimes decades. What humanity experiences in 2026 is not the result of decisions made last year or even 5 years ago. It's the delayed response to emissions released decades earlier, environmental damage that is already locked into the system, and natural cycles now aligning with human impact. In other words, the planet is reacting to a past we can no longer change. Even if all global emissions stop today, completely and immediately, Earth would continue adjusting. Oceans would keep warming as they release stored heat. Ice sheets would continue melting. Weather patterns would remain unstable as the climate seeks a new equilibrium. This concept is known as climate inertia. It's why scientists are clear that preventing further damage, while essential, is no longer enough on its own. Adaptation is now unavoidable. That means strengthening infrastructure to withstand extremes that are no longer rare. Power grids that can survive heat waves and storms. Water systems designed for both drought and flooding. Transportation networks that don't collapse under stress. It means smarter cities, built with climate reality in mind, not historical averages. Cities that manage heat, conserve water, protect coastlines, and respond quickly to emergencies. And it means prepared communities. Because resilience doesn't start at the national level, it starts locally. Neighborhoods that know how to respond. Healthcare systems that can scale during crises. Food and energy systems that can function even when supply chains are disrupted. Scientists emphasize this shift in focus not because they've given up, but because they understand how Earth works. The phrase, "this is just the beginning," doesn't mean the worst is inevitable. It means the next phase is already unfolding. The choices made now will determine how severe or manageable that phase becomes. There is still time to reduce risk, to limit damage, to protect lives. But there is no time left for denial. The future is not waiting for humanity to catch up. It is already responding. And while the path ahead remains uncertain, one truth is clear: the planet will continue to adjust, whether we are ready or not. What matters now is how prepared we choose to be. Because adaptation is no longer optional. It is the bridge between the world we inherited and the one we are rapidly entering. Earth isn't angry. Earth isn't punishing humanity. Earth is reacting to pressure placed on its systems, reacting to imbalance built up over time, reacting to change, both natural and human-driven. That distinction matters, because 2026 is not the end of the world. But it may mark the end of a dangerous illusion, the belief that everything will continue as it always has, that stability is guaranteed, that tomorrow will look like yesterday. Scientists aren't asking us to panic. They're asking us to pay attention, to listen to the signals the planet is sending, to recognize that warning signs are not predictions, they are opportunities. Opportunities to prepare rather than react, to adapt rather than deny. The choices humanity makes now will echo far beyond the next few years. How communities prepare for heat, storms, and disruption. How cities are designed for resilience, not just growth. How nations cooperate instead of competing during crisis. And how individuals look out for one another when systems are under stress. These choices won't just shape climate outcomes, they will shape human outcomes. This moment isn't defined by fear, it's defined by responsibility. Because awareness changes behavior, awareness drives preparation, and preparation saves lives. Earth will continue to adjust. That much is certain. What remains uncertain is how wisely humanity responds. History shows that civilizations don't collapse because of change. They collapse because they fail to adapt. 2026 is not a deadline. It's a wake-up call. And awareness, clear, informed, and shared, is humanity's greatest survival tool.